Planet Earth is protected by the atmosphere, the layer of air and gas that surrounds it. The atmosphere shields the Earth from solar radiation, keeps the temperature balanced, and protects us from meteoroids. On the Moon's south pole, you can see almost perpetual sunlight on the horizon. This is the site of our lunar base. Conditions on the Moon are very different from those on Earth. Because the Moon has no atmosphere, there is no protection from solar radiation. There are extreme temperature fluctuations, and there is no protection from gamma radiation, and no protection from meteoroids. The lunar lander has detached from the rocket launch and is on a course to Shackleton's crater, the Moon's south pole. Inside the lander is a cylinder which contains an inflatable dome and 2 robot 3D printers. After the cylinder containing the habitation capsule has been unloaded, a dome is inflated from one end. This provides the support structure for construction. A little like scaffolding is used to build on Earth. The lunar habitation is built by a robot-operated 3D printer. At one end, it has a scoop to collect the regolith. In the centre are the containers for the printing material. At the other end, there is a robotic arm with a printing head. The robot collects regolith from the Moon's surface. Layers of this moon dust are built up over the dome to create the protective shell. This process takes about 3 Earth months. The shell is made up of a hollow, closed cellular structure. Under a microscope, it would look very similar to the close-up of a bird's bone. Like a bone, it is light and incredibly strong at the same time. When the lunar base is complete, it can house 4 people. Inside the dome, they are protected from meteorites, gamma radiation, and high temperature fluctuations. The original capsule functions as an airlock and technical support module. The skylights draw daylight into the living and workspaces, which are sheltered within a pressurized enclosure. This method is a pioneering advance in space-age construction. At Foster & Partners, we're used to designing for some of the world's most extreme climates. We often use materials found locally to create sustainable buildings on Earth. While the Moon is an exciting new territory for architecture, the value of this logic endures.
Five, 3, 2, 1, 0.
The Cosmic Infrared Background Experiment, shortened to CYBER, is a series of 4 rocket measurements designed to improve our understanding of the infrared glow that fills the sky. CYBER has measured unexpectedly bright irregularities in the glow at the shortest infrared wavelengths, which we interpret to be due to stars tossed out during the assembly of galaxies. During this process, some stars are flung far from the galaxies and are no longer strongly associated with them, as highlighted by the slowly moving yellow regions. As the 2 galaxies continue to interact, forming a larger galaxy, more stars are lost, and regions far from the host galaxy begin to light up. Over time, the lost stars move on random orbits and fill in a huge halo around the central galaxy. As we zoom out, showing more galaxies, we see that a similar process occurs throughout the universe. In the CYBER result, we isolate the large, faint halo light, which appears in the real data as fluctuations at large scales. These images suggest there may be as much light in the vast spaces between galaxies as in the galaxies themselves.